The goal of today is to be able to calculate lateral and surface area of prisms and cylinders. Just a reminder, a prism is a polyhedron, which is a three-dimensional shape that is made up of polygons. And a prism has two congruent parallel faces called bases. So it is important to recognize that they are congruent and parallel because you need to be able to pick out which ones are the bases. That's going to be important. The other bases are called lateral faces. Your lateral and surface area prisms can be found by adding the area of each individual face or by using the formula below. So we've included the nets for each of them. So if you want to do each individual shape, because if you recognize that the prisms are broken up and they're made up of any of the polygons, rectangles, squares, triangles, hexagons, heptagons, whatever the shape is, we know how to find the area of all of those because of our previous units. So you can just find the area of each individual one and add them all together like a composite shape. Or you can use these formulas. I highly recommend using the formulas because they work the same all the time. Now what's important about the formulas is this. P stands for the perimeter, which means the sum of all the sides of the base. B stands for the area of the base. So that's what we did in the last unit. And then H is the distance between the bases. Now, because of these designations, what I recommend is that you have a highlighter where you can mark your capital B base and your H, your height between the two bases. Now, you're going to have to go back and forth between two-dimensional and three-dimensional numbers. So we have our little b for base, like the base of a triangle, and the height of the triangle. So I will always specify when I say the base of the triangle, the height of the triangle, I'm talking about the two-dimensional shape, which is our base. So here's what it'll look like. We have this rectangular prism, and so we can pick our base. Now, the base is not always the one that it's sitting on. I'll show you one in just a second. But if you ever have, if it's all rectangles, then your base is a rectangle. So I like to use the one that it is sitting on. You don't have to, but you can. So that is your B. That's your big B. Okay? That is your big B, your base. And then your height, because then there's this base up here too, but we only need one base. But it does say that they are congruent and parallel. So those are your two bases, those two that I've highlighted. And the distance between those bases, that is the H that you're going to use in the PH and the PH plus 2B. So the first thing that we want to do in all of our problems is we need our perimeter. And what I mean is the perimeter of the base, which is the perimeter of this shape. So the perimeter of that shape is 6 plus 2 plus 6 plus 2, which is 16. And then the area of the base. Just focus on the yellow rectangle. Okay, this is a rectangle. Focus on that rectangle. The area of a rectangle is base times height. It's the base of the base is 6 and the height is 2. Now that's the height of the rectangle, right? We're just ignoring everything else and we're just going to get that. So to get your P and your capital B, just look at the rectangle. Just look at the base. Whatever it is, that's 12. And then your height, anytime you have an H and you're using lateral area or surface area or volume, you're going to use that H. Now, all these, just so you know, all of these are on your formula chart. This is a prism, and so it's PH and then PH plus 2B. That means you have to know what a prism looks like. Okay, so now we have it. So our lateral area is PH. Our perimeter was 16. And our height, which is the distance between the bases, is 4. 16 times 4 is 64. So the lateral area is 64 meters squared. What that represents is all of this. This is the area of all of the rectangles on the side, not including the two yellow shapes. Okay? Then surface area is your lateral area, PH, plus 2 times the base. Well, PH we just found was 64 plus 2 times the area of the rectangle. The area of the rectangle was 12, and there are two of them. There's a top and a bottom that both have an area of 12. So 64 plus 24 is 88. And so the surface area, which is the area of every surface in the figure, is 88 meters squared. Okay, so let's look at this next one. So anytime in a prism, if you have a shape other than a rectangle, that is the base. So highlight that base, make it stick out so that you know to look at it. This is your big B, right? This is what you want to find the area of. This is what you want to find the perimeter of. And then your height, or your H for your pH plus 2B, is right there. That is, it's always perpendicular between the two bases. So we have the triangle on top and we have the triangle on bottom, and 3 is the distance between them. Okay, so now ignore the rest of the shape for just a second and let's find the area of this triangle. So the area of this triangle, you go back to your formula chart. The area of a triangle is 1/2 the base of the triangle times the height of the triangle. So 1/2 the base of the triangle is 5, and the height of the triangle is 8. Remember, we always look for this perpendicular, right? We always want to look, base and height are always perpendicular. So 1/2 of 5 times 8 is 20, half of 40, which is 20. That's your B, that's your capital B. Then we also need our P, which is our perimeter. Okay, well now we run into a problem. I don't have that information given because this is the side that we need. Perimeter means the sum of all the sides. So I have 5 plus 8 plus something. So we have to go over here to the side for just a second and let's go find it. Well, I have 2 of the 3 sides of a right triangle. That means I need to do Pythagorean theorem. Okay, A squared plus B squared is equal to C squared. 5 squared plus 8 squared is equal to that missing side squared. Type that into your calculator, and you can let the calculator do all of the work for you. The square root of 5 squared plus 8 squared, because we want to take the square root of C squared, we want to take the square root of both sides. And we find out that this side is 9.43. So my perimeter is 9.43. I'm just going to use the number that's in the calculator, plus 5 plus 8. And you get that the perimeter is 22.43. Okay, now that's the perimeter of the base. Remember the reason that we had to do Pythagorean theorem is because we needed that side of the base so that we could get the perimeter of the triangle. We've got the perimeter of the triangle. We've got the base of the triangle. So we've got the area of the triangle, which is the base. Now we can need our formulas. So lateral area of a prism. This is still a prism. It's a triangular prism. That's pH. Well, I just found P. It was 22.43 times the height. Now this time it's the height. You have to leave the triangle, right? Lateral area is a three-dimensional measurement, so you have to leave the triangle. If you do 5 times A, if you do P and then you choose height from here, you never left the triangle. Remember, the H is the distance between the triangles. This is the height of the triangle, right? This is the height of the prism. That's the hardest part about this entire unit. So I'm going to keep that again still where I had it. I'm going to multiply that by 3 because we never want to round until we get to the end of the problem. And that's 67.3 centimeters squared. That is the area of all of the rectangles. So what you could have done is you could have said, well, this is 3 by 5, and this is 3 by 8, and this is 3 by 9.43. And you could have found the area of each of these and added them all together. That's how you can use a net to do this problem. So if the formulas mess you up, then don't use them. Just find all your sides, break this up into a net. And then your triangles, these pieces right here, these are your bases. Okay, that's your base. So then your surface area would be, I want the area of all of the surfaces. So that's pH plus 2B, or that's 67.3 that we had right here, plus 2 times the bases, which was 20. The top base was 20 and the bottom base was 20. So plus, I'm going to keep that, plus 2 times 20. And we get 107.3. So the surface area is 107.3 centimeters squared, and that is every surface, all 3 rectangles and the 2 triangles. You would get the same thing if you did 3 times 5 plus 3 times 8 plus 3 times 9.43 plus 20 plus 20. Okay, because this is 5 by 8 and this is also 5 by 8. So you can do that. That's another option. Now this one is one where it throws people off because you always want to use the base as what it sits on. But if you think about it, the base of a lamp stays the base of a lamp even if the lamp gets turned over on its side. Okay, so this is just a prism that got turned over on its side. The bases are congruent and parallel. So you want to find the sides that are both congruent and parallel. Well, these rectangles are congruent, but they're not parallel. The only thing that is congruent and parallel is this triangle is parallel and congruent to this triangle in the back. That is your base. So that's your B. That's what you use for your B and your P. And then this is what you use for your H. Okay, this is your B and your P, and this is your H. Every time, B and P and H, B and P and H. Okay, so we need the area of this triangle and the perimeter of this triangle. Well, perimeter is easy. I already have all the sides. So 16 plus 10 plus 10. And you get 36. So the perimeter is 36, and then the area of the base. Ignore everything else and find the area of that triangle. Now we have a problem. I need the area of a triangle is 1/2 the base times the height. The base of the triangle times the height of the triangle. I don't know the height of the triangle, but I do know when you drop this height down right here, it cuts this base in half. And we've got that right triangle for a reason, because now what we want to do is use Pythagorean theorem to find the height. Again, anytime you have two sides of a right triangle, you can find that third side. So you take a stop, you take a break for a second, and you say 8 squared plus b squared is equal to c squared. C is always the hypotenuse. Okay, now because they're on opposite sides of the equal sign, you have to do an inverse, so you do 10 squared. Now be careful, it's 10 squared minus 8 squared, not 10 minus 8 and then squared. So 10 squared minus 8 squared is 36. The square root of both sides is 6. You can do that all at once if you like to. You can do 10 squared minus 8 squared, and you get 6. So the height of the triangle is 6. Now I have what I need to find the area of the triangle. So it's half the base, which is 16, times the height, which is 6. Because all I'm focusing on is the triangle. That's all I care about. 16 times 6 divided by 2, and you get that the area of the base, the area of the triangle, is 48. Now that you have that, you have your big B, you have your P, and you have your H that you need for your lateral area and surface area formulas. Lateral area is PH. This is a triangular prism. PH is what you want to use. So it's the perimeter, which is 36, times the height of the distance between the bases, which is 25. 36 times 25 is 900. It's 900 meters squared. That is the area of each of the rectangles. You can do that all here. You can do the same thing. You can do, it's 25 times 10 and 25 and 16 and 25 and 10. So you've got all your rectangles. You can add those all up, and then you add your two bases, so you add your two triangles. So your lateral area was PH plus 2B, that's 900, plus 2 times the area of your base, which was 48. 900 plus 2 times 48, and you get 996 meters squared. If you're getting confused, then break everything up into a net, put all your measurements onto your net, and then find each of the pieces. Your lateral area is your rectangles, your surface area is your rectangles and your triangles. Okay? And when you don't have what you need, don't forget Pythagorean theorem. Now, what if we take a pencil? Pencils are regular hexagonal prisms. The base edge has a length of 4 millimeters. The pencil without the eraser has a height of 170 millimeters. What is the area of the surface of the pencil that gets painted? Now, think about it. All that gets painted on your pencil is the sides. So the base, the hexagon part, doesn't even get painted. So what we're looking for is lateral area. That's the part we want. We only want this much of it. because this is all that gets painted, is all those rectangles. So that's the lateral area. It's a prism, so lateral area is pH. So we need the perimeter of the base. Well, the base is a hexagon. It has a side length of 4. So each of these sides is 4. 4 times 6 is 24. So perimeter is 4 times 6. That's 24. And then the height is the distance between the two bases. So this measurement right here, that's your height. And it's 170 millimeters. So the area of the pencil that gets painted is P, which was 24, times height, which is 170. 24 times 170 is 4,080 millimeters squared. It's important to know that because then if you're manufacturing those pencils, you need to decide how much paint to buy, and you know how much area the paint will cover, and so that gives you an idea of how to decide how much to buy. Okay, now so we'll switch to cylinders. Cylinders are similar to prisms. They're a little bit easier though because the base is always a circle. So the lateral area and surface area of a cylinder, the lateral area, think like that's the wrapper. So this is your lateral area. It's just that rectangular piece. Your surface area is your rectangular piece plus your two circles. Now, it is on the formula chart again. Your lateral area is 2 pi RH, which is still pH. It's just 2 pi R is the distance around the circle. So the distance around the polygon, or the distance around the circle. And then it's that same thing. It's your lateral area plus your two circles. Pi R squared is a circle, and 2 pi R squared is the top and the bottom, or the front and the two circles that go with it. So lateral area is 2 pi RH, and surface area is 2 pi RH plus 2 pi R squared. This is the rectangle, and this is the rectangle plus the two circles. Okay, so always write the formula. It's helpful. This is a cylinder. Lateral area is 2 pi RH, so I want to find the lateral area. Lateral area then is 2 times pi times the radius, which is 3, times the height, which is 6. So you can type out all of that in on your calculator, or you can, we leave it exact. Let me show you this. Most of the time we'll just have you round, but I want you to see it. So if you type in 2 times 3 times 6, this is 2 times pi times 3 times 6, but I just typed in 2 times 3 times 6, you get 36. So I did everything except the pi, so I'm going to leave 36 times pi there. That's called an exact answer. So if you ever see it like that, it's exact. But you can also take that number, and you can take 36 and actually use the pi key and hit it, and you get, then it is approximately 113.1. Because I've decided that those decimals are not important, so I'm going to round it, and so this is approximate. Now this is rounded to the nearest tenth. Total area is 2 pi RH plus the two circles, 2 pi R squared. So we're going to take this 113.09 that we already had, and I'm just going to leave it in my calculator. You always want to leave it until you get to the very end, plus 2 pi R squared. R was 3. So I'm going to take this previous answer, I'm going to add 2 times pi times R squared. And you get 169.6. And that is in meters squared. So the lateral area, what that represents is this piece right here. It would open up to be a rectangle. It's the wrapper around the soup can. The total area is the wrapper around the soup can plus the top and the bottom. So that would be how much metal it takes to wrap the whole can. Okay? A cylindrical carton of oatmeal. So as soon as you read that, you might want to draw something, right? A cylindrical carton of oatmeal has a radius of 3.5 inches and is 9 inches tall. If all surfaces except the top are made out of cardboard, how much cardboard is used to make the oatmeal carton? Assume no surfaces overlap. round your answer to the nearest tenth of a square inch. So in this case, you can't do lateral area or surface area. You actually have to kind of use what you understand. Well, really what we want to do is, if you look at this total area and what it encompasses, total area, we need the 2 pi RH. We need the lateral area. But we don't need 2 circles. We only need 1 circle. So we want to find the lateral area. Lateral area is 2 times pi times the radius times the height. So that's 2 times pi times the radius, which was 3.5, times the height, which is 9. So I find that out, 2 pi times r times h. I get that the lateral area is 197.9, just to write it down, okay? And inches squared. That's the lateral area. But I also need to make the bottom so the oatmeal doesn't all fall out. So I need to add 1 circle. It says no top, except the top. With word problems, you always have to make sure that it makes sense. So we're going to just add 1 circle. We only want one circle, the bottom. Area of a circle is pi r squared, so it's pi times 3.5 squared. So if we want to take this original number and we want to add 1 circle, so I'm going to take that original number and I'm going to add 1 circle, not 2. Circle would be top and bottom. So total, it takes me 236.4 inches squared of cardboard to make a cylindrical carton of oatmeal with no lid. Okay, it's all about the formulas. There are 2 bases in cylinders and prisms. The difference is what shape they are. You always want to be careful. Make sure you find the area of the base and the perimeter of the base. And then the h is the distance between the bases. That's where you have to be careful, is this h right here. This one always causes the problems. But you have to remember that you're pushing that back into 3-dimensional space. And so you've got to take that triangle and push it down. If you can imagine that you're pushing that triangle down, and that's how far you're pushing this triangle until it matches up with that triangle.